Well, good morning, everyone. I'm Abhijit Majumdar. I'm a senior developer for AI at Plus One Robotics, and today I'll be talking about problems with vision for complex applications. The application domain that I'm going to be focusing on is robot manipulation using vision for partial induction. And this is typically done with RGBD sensors and the data from which can be used for a variety of applications like partial sortation, bucking, palletization, depalletization, etc. The objective of my talk is firstly to show what works and what does not, sort of a validation for research out there, and also knowing well that there are solutions, we want to promote more research in these fields that have issues with them. So to start off, I'd like to talk about sensors. Every sensor has a different noise profile, and you'll be able to see in this image soon that examples of a D415 and a 515. The problem is if we typically in production use one type of sensor, but then as soon as that goes to production, this becomes an issue. Additionally, if you're training, say, a deep model here, you're typically trained using images or data from one sensor. So that's another issue. The solution, the suggestion that we have for researchers to research more on noise profile modeling for a particular sensor to address this problem. Another observation we had is that the data is not good for package simulation. You'll see in this video, it's very hard to make out what is a package, how many packages are there, and things like that. But and that's because the noise variances within the depth of the package. But as soon as you turn on RGB, you can make that out. And
I think we're just lagging for a second.
yeah.
Your simulation is too high quality. So,
Oh,
yeah.
man.
There you
go. So clearly the solution is better RGB sensors, faster, more accurate, and across a radius surface. Also, I'd like to talk about how there's a lack of simulation for real sensor. There are several simulators that are trying to simulate more and more realistic environments. That's really awesome. But what's lacking in our opinion is how these realistic simulations look from a real sensor out there. This actually ties back to the noise profiling that I was talking about, because only when you simulate that. So that's actually our suggestion as well, is to emulate these real sensors in these simulators. I'm going to talk about data. Data is very limited in this domain, and it is crucial to collect data on site. We cannot just run on the lab data because a warehouse environment is highly variable from sea level lights, reflected floors, to moving objects. Obviously, augmentation helps. We have shown that we have proven that to ourselves. It's also proven, in research, but it only works up to a certain saturation point. Long tail problems is also a typical issue. As an example, brown boxes are very common, but computers you have these seasonal packages that completely screws off your model then. So our recommendation to researchers is to publish more metrics on outcome distribution data and imbalance data on their models that they're developing. I want to also talk about imbalance in data for subcategory of products. And to explain that, I'll try an example. Consider you collect data on site. This is random sampling, right? And then you label it in three categories: polydiaphos and flat mirrors. Because it's labeled now, you can balance it before training. But however, despite that, the box data typically has a large skew towards brown boxes because they're more popular versus multicolored boxes. And our recommendation here is to develop more tools to isolate packages based on their attributes. So things like embeddings or unsupervised learning models. Finally, I want to talk about models. With everything I've said just now, the model needs to handle failure modes. While doing it, while model is being updated, there needs to be more refreshment. Things like data compression using data distillation or faster retraining by means of prompt learning, improve backpropagation are obvious ways to go. But the increased models in this field. Right, labeling is very expensive. This is an often overlooked point, but it has a very high payback in industry because it's not sustainable. An obvious explanation is, train with less data because then that way you get label-less data, or filter failure modes better, so have more accurate confidence scores so that you can filter those out better. All right. So if you combine everything that I've shown, this looks like a typical training, a deep training paradigm. But all I'm trying to show is points where this can be further and better optimized. That's it.
Thank you.
Thanks.